In grade school, we learn that if I want to take some number divided by a fraction, so here I'm doing 50 divided by 4/3. Well, what we do is we change the division to multiplication and we flip the fraction. So dividing by 4/3, we're told is the same as multiplying by 3/4, multiplying by the flipped fraction or the reciprocal. Now, if we go ahead and do this, well, then we get 150 over 4 because we know that anything over a 1 is just itself. 50 over 1 is 50 because how many groups of 1 can I take out of 50? Well, 50. So basically, you could think of this as over a 1. Those would multiply to get that. Those would multiply to get that. And then we get our answer. I'm not concerned about the answer. I'm just really wanting to look at this. So I want to give an intuition on this first before I give a proof. So let's think about what if I wanted to take 100 and I'm going to put it over 1 just to facilitate what I'm doing. And let's multiply that. So I'm not doing division right now. Let's do 100 times 5/2. And so what would happen would be 500 on top, 2 on the bottom, and we would get 250. And I want you to think about what multiplying by a fraction actually does, because really only the top multiplies, the bottom actually divides. Notice this 2 slid under the 100, or well, under the 500 in this case, and it cut it in half. So this multiplied and this divided. Well, now let's think about what if I wanted to go the other way. What if I wanted to get from here back to the 100 that I started with? So let's start with 250. And again, I'm going to put it over a 1. And now instead of multiplying by 5/2, I'm going to divide by 5/2. I'm going to do the opposite. Okay? Well, so let's think about again what happened. What did this fraction do when we used it to multiply? Well, the 5 actually multiplied and the 2 actually divided. It cut it in half. If this hadn't happened, this would be a 500 instead of a 250. So, so when we do the opposite of this, well, forget about this for a second, and let's just think what we would do logically if we wanted to do the opposite of what we did here. Well, we would naturally, instead of the 5 multiplying and the 2 dividing, we would make the 2 multiply and the 5 divide. And then that would give us 500 over 5. And hey, guess what? We're back to the 100. And so just looking at the fact that we wanted to do the opposite of this, which really is just this, which when it's carried out actually turns into this, well, then it makes sense that dividing by 5/2 would have to be the same as multiplying by 2/5. Okay, now let's do something more rigorous. That's what we say about proofs when they're not an intuition. We're actually proving it in a way that can't be disputed. So let's go back to, let me line this off and I'm going to prove it for just the numbers that I'm using as an example, then we'll prove it generically. So I'm going to manipulate this now. I'm going to do 100 over 1 divided by 2/5. And now I'm going to do something that we know based on a property of fractions, that I know that I can multiply 1/2 by any number I want. Let's just say, I don't know, 3. I'm going to multiply the top and bottom by 3. So that would give me 3/6. And we know 3/6 of a pizza is exactly the same amount of pizza as 1/2 of that pizza. So it's very well known and easily proven that you can multiply the top and bottom of a fraction by any number you want, as long as you do both the bottom and the top, because multiplication and division are by nature, they just produce ratios. And so this is just a ratio of this. So what I'm going to do right now is I'm going to choose to multiply the top and bottom of the fraction by something. I'm going to multiply them by 5/2. I'm going to flip this and multiply the top and bottom by that. Okay. Well, on the bottom, notice this is just going to be 10 over 10, which is going to be 1. And now the top is going to be, I'm just copying, it hasn't changed. And now we can dispense with the 1, and we get 100, and I'm going to dispense with that 1 as well. We get 100 times 5/2, and there we go. Dividing by 2/5 is the same as multiplying by 5/2. Well, to finish, let's go ahead and do a generic proof. So I'm going to do a fraction a over b divided by c over d. And this could include an integer too, because b could always be 1 and a could be whatever, some integer. And so we'll just make them both fractions. And I'm going to do the same thing I did here. So basically, you already know what I'm going to do. So I'm going to write the division as a over b divided by c over d. I'm going to go ahead and multiply the top and bottom by d over c. And we get 1 on the bottom, and on the top we get a over b times d over c, which is a over b times d over c. And we have proven that dividing by c over d is the same as multiplying by d over c. I'll close with a fun fact few people know. So let's make up an example. So I'm just going to do 15/4 divided by 5/2. And let's go ahead and do it. So we would change to multiplication by 2/5. That would give us 30 over 20, which would reduce to 3/2, because literally we're dividing the top and bottom by 10. So you could do it like this. Okay, so and then that would give us the 3/2. So notice, I should have mentioned this earlier, but whenever we do this where we multiply the top and bottom by the same thing, we're just creating a 1. So 1 times this has to be this. It looks different, but it's actually unchanged. But now what I want to show you is, let's take this thing here again. And what I want you to see is, just as if this was multiplication and we multiply across the top, multiply across the bottom, we can do the same exact thing with division. So 15 divided by 5, 4 divided by 2, and there we go. It's the same thing. So you can do exactly like multiplication with division. The only reason we don't tend to do that all the time is because, if ever, is because this worked out nice because this divides this and this divides this. But otherwise, you can get some decimals or fractions or whatever that you don't want. And so that's why we tend to go from this to this first.